We're back. And here, off to the races here. My favorite topic and one of my favorite hobbies is to find new terpenes for your exams. So you'll see all these exams where those terpenes there were newly found by me by doing literature searches. Yours will be new ones too. So, what is a terpene? Great question. You're going to say, okay, we're studying chapter 5. It's all about alkenes. They must all have alkenes. And I say, oops, no alkene here. So you're saying, oh, they must have pi bonds. Uh-oh, no pi bonds here. And then you're saying, I don't know what to say now. What do they all have in common? I'll tell you what they have in common. Watch and listen. Let's go. 1, 2, 3, 4. 1, 2, 3, 4. There's always a 4-carbon chain with a branched single carbon off of 2. And it repeats. That repeating pattern is what makes these terpenes. 2, 3, 4. 1, 2, 3, 4. Oxygens are unimportant as to being terpenes. They can be there. They're functional groups. They give terpenes their function, but the skeleton is what really makes them terpenes. Menthone, we can go 2 ways. 2. And I could have started my 1s over here as well. That doesn't matter. Then the other thing would be the branch. 1, 2, 3, 4. And then 1, 2, 3, 4. Menthol has the same skeleton, but I'll go the other way just to show you. We could have got the same pattern. 1, 2, 3, 4. 1, 2, 3, 4. And we circle these things. And there's a name. Every time you have the repeating pattern, you circle it. And that's called an isoprene unit. And you need a minimum of 2. And everything on the top of the screen has 2 isoprene units. And even caraway seed molecule version of carbone has 2. And 2. I missed 3, didn't I? Careful. Sometimes the branched carbon is not a CH3. Like in our first example, we had a C. Hey, we got a name for it now. It's a methylene. That's not important. The position of the double bonds is irrelevant. It's the fact that there's a carbon sticking off of 2 and it's all by itself. That means it's the branched carbon. Okay? Same thing here. You could have gone 1, 2, 3, 4, or 1, 2, 3, 4, in which case your branch would be a methyl, but it doesn't matter. And I think you're getting the idea that we can do this for all of these. And got 2 circles in all of those. These are cool. They got this bicyclo stuff going on. These are all very odoriferous too. This camphor and menthol are together in Vicks. You rub that on your chest to open up your bronchioles and breathe better. And camphor is really intense. Now you gotta be careful with camphor. Notice I started up there with the dimethyl. That's always a good logical place to start. Now you can't go here for your 3 because then this guy never gets to be part of anything. You got to go here for 3 and then you can go left or right. You'll be doing these circles on your test. I'm going to do a sample test question very soon. And then this thing would go 1, 2, 3, 4 here. Notice each carbon gets circled only once. And notice what I do with oxygens. I pretend they're not even there. Oh, I didn't over here, did I? I circled it. I wouldn't give you a hard time, but it's not really part of the isoprene, is it? There we go. There. Ignore oxygens, ignore atoms that aren't the carbon skeleton. So all of these up here, 10 carbons. The classification is called monoterpene. The system is based on multiples of 10. And how did I know there was 10 carbons? How many circles in each of them? 2. How many carbons in each circle? Careful, there's 4 in a row, and the branched one off of carbon 2, that's 5. So you always have multiples of 5 carbons, don't you? Over here, there's going to be 3 circles. You ready for them? Let's start doing them like they're a test question. I'll show you what I do. I'm going to get my snipper, show you the steps. Snipper doodle. I just need the picture, don't I? And we'll paste it here. ZV. We'll blow it up. Copy it. Maybe need 2 more times. First thing I do is put on the 2s. I know where there's a dimethyl, it's always a 2. One of them is a number 1. One of those 2 methyls is a 1, and the other's the branch. Dimethyls are nice. They happen very frequently, and they're nice places to start. I'm just putting the 2s on. And then I'll redo it because I should have thought ahead and copy pasted from there. That's okay. After you do that, go back to your dimethyl if there is one, and put a 1 on one of the methyls, and then figure out where the 3 is. Notice I said figure it out. I would do this with pencil, not pen, because if you mistakenly put I'm going to do the wrong thing first and show you why it's wrong, and then start over. If you go 3, 4 here, you're in trouble. What are you going to do down here? Is there any way to attach a 1 to this? This would be 1, 2, and dead end because you already counted a 4. You can't count carbons more than once. So there's no way to make this part of a branch to chain. So the 3, 4 situation you chose was bad. There's only one other way to do it. Well, there's 2. This would be even worse because this guy will never get circled. You got to be attached. And this guy is not going to be part of a branch carbon. So the 3 was good up here. The 4 is there. All right. And then I don't need the last one. This thing finishes itself now, doesn't it? If that's a 1, well, let's say it's a 4, which would be silly. 4 isn't connected to 2. It can't be a 4. It's got to be a 1. And then the rest should finish itself in baby blue. Oh, I want all 5 carbons circled, please. Oh, it's okay. I need to clearly see 5 carbons in your circle. Don't leave the branched carbon outside your circle. Okay. Now, there's something called connections here too. Before we do connections, let me just jump over here. Okay. Here is an isoprene unit. We say that carbon number 1 is the head and carbon 4 is the tail. And if you're not seeing that, then bear with me on this silly example here. I am not a good artist. I don't know. He's going to have it's going to be it's supposed to be an eyeball. And he's going to be terpene monster. Those are supposed to be teeth. This didn't work at all. So you can tell where his head is. It's number 1, right? And the tail is called number 4. So on the test, you're going to be asked to give connections between the isoprene units. I have the same page I have a blank version of this page after it. This is a head to tail on the test. Don't call it 1 to 4, please. H to T. See page 7. On the test, it's going to say clearly, I don't want to see the head to tail connections. I'm telling you where they are. They're what we call garden variety terpene connections. Every terpene has at least one, and they're kind of boring. But over here, connecting the green circle to the baby blue circle on the left, that's carbon 2 connected to a tail. Remember, 4 is called tail. That one I want to hear about. And over here, I have the green 3 connected to the blue 3. Now that is a rare connection for a terpene. It makes caryophyllene a cool molecule. That's a 3-3 connection. The only 2 parts that have names are head for 1, tail for 4. Okay, so I will leave it up to you to practice. There's lots of, anytime you see a terpene in this chapter, go practice with it. And there's lots of practice. Every exam's got practice pages of terpenes. There's no shortage of terpene practice available to you just at Moodle and in your textbook. We have to know the classification system. It's easy when it's 10, 20, 30, 40. We go mono, di, tri, and tetra. But the other ones all start with SES, don't they? And they don't even go in order of smallest to biggest. It goes medium, small, big. Sesquiterp. Sesqui is a fairly common prefix in English. Means 1.5. 1.5. If you're Canadian, you had the sesquicentennial celebration a couple years ago. Canada turned 150. I think it was the year after Wayne State University turned 150. Little trivia there for you. And if you have, how many circles would you need to be a sesquiterpene? Because we just saw one. 3 circles, because it's 1.5 times 10, which is 15. There you go. Sesqui means 1.5 times 10. Mono means 1 times 10. Boom. All right, so on the test, when I give you your terpene, you'd have to put the classification too. So you'd say this is a sesquiterpene. Got 15 carbons. Don't count the carbons, count the circles multiplied by 5. There you go. And we might as well get right to the real test question. And so learn this table, it's in the book. And then we go fall 14. I wanted to go to the Wayback Machine on this one. This has all the parts you're going to have for sure. It's got 2 copies. On your test, it will not be like the exams from previous semesters where there's this is one terpene, half the questions done on the left, half on the right. Every semester it's been another pair of terpenes that are the same down here. Not for you. We're trying to cut these things down. So tell me where we want to start. We're going to do the circle the isoprene units. It's a lot of points. I gave you the point count earlier today when I directed you towards the layout for test 2. So read that email. And what am I doing here? I'm putting the 2's down. It's where there's a branch carbon. Now down here, do not be fooled. There's a 2 that it's not obvious, but I hope it's obvious after I point out the fact or remind you of the fact you're supposed to ignore oxygen. So pretend the oxygen's not there, and that makes this carbon all by itself. That makes the carbon attached to it a 2. That's the carbon all by itself. Sadly, you can't use the strategy of starting on the carbon that has a dimethyl, because this is a rare terpene that doesn't have a dimethyl. Don't panic. This is not really a hard one. I like starting here because this carbon can only be one thing. It can't be a 3. You'll never get to carbon 4. It's got to be a 1. Remember, ignore the oxygen. It's not there. And this carbon's not connected to this carbon. It's connected to the oxygen. So you can't really ignore it. I mean, it's the dead end for this carbon right here. 1. Oh, don't put it in blue. 2's first. Blue 2. Now, do we go 3? Yeah, there's only one way. 3. And, well, you can't call that 4. It's not a carbon. 4. 5 carbons in the circle. What is this? I don't know. Might be a 3, might be a 4. Cross your fingers. If I go 1, 2, 3, 4, you're in big trouble. 1, 2, 3, 4, this never gets circled. Bad choice. How about 1, 2, 3, 4? I think that works very well. Five carbons in the circle. And there's a head to tail linkage. Label each isoprene connection that is not head to tail. I'm not going to label this one. If I do on the test, you're not going to lose points. You're wasting your time. What does this have to be? Can't be a 3. Can't go 2, 3. That'd mean never be a 4. It's got to be a 1. 1, 2, 3, 4. I think this thing finishes itself. I came awful close to that carbon. Oh. I do not like even seeing a hint of a carbon in 2 different circles. What does this have to be? Can't be a 3. It's got to be a 1. How about a good old orange here? Pen's off. Orange. And it does finish itself. Oh, I don't like it. The circle's almost touching each other. And I got rid of my numbers again. 1, 2, 3, 4. And then at the end, purple. 1, 2. Can't be 3. That's a bad choice. 4. 5 carbons in this circle. Are there any connections that are not head to tail? There's a head to tail there. I don't want to hear about it. There's a head to tail here. The red 1 is covalently bonded to the green 4. Head to tail. There's a tail to tail right here. Let's put these in, basic black. And there's a head to head over here. That's the only 2 connections that are not head to tail. Right here's a tail to head, which is the same as head to tail. This is not a connection. There's an O in the middle. 2 is connected to 3, but there's an O. I need direct connections between isoprene units. So there's your only 2 funky connections. All right, so we've done part A and B. Part C, count your circles and figure out how many multiples of 10 you got. 1 circle, 2, 3, 4, 5. 5 is 25 C's. You need the prefix that means 2.5. And that was the cis terpene. There are other books. This is really weird. They got the ter twice. Cis terpene. Okay. If you put that, I'll give it to you, but it's not on any practice exams. Okay. What else? Functional groups. We're not supposed to do those here though. Parts A, B, C are done. Left side of the, well, left of the page is A and B, middle for C, D. It just makes it easier for me to grade if you spread your answers out. Oh, the old stereo centers. Do they ever go away? No. All of chapter 3 is on your test. That first bit of 3 we learned earlier was just a warm-up. Okay. I've been doing this for a long time, so I see there's an H there. That's one group. There's a methyl. There's a C with 2 bonds to C and a CH2. They're all different. I'll just quickly get these on here for you. Please, no sp2 carbons ever. An sp2 carbon only has 3 things attached. Definition of a stereocenter, 4 different things are attached. So I was really sad when students were putting asterisks on things like carbonyls. That's never true, never sp2. But these all have 4 different groups, and that's it. Don't go putting any stars or asterisks or whatever you want to call them down there. Don't go here with an sp2. All right, functional groups, we have an ester. We have an ether, both here and here. And I think that's it for functional groups. Now, some of you, if I told my Orgo 2 students this was an ester, they just learned that a cyclic ester has a different name. I'm not even going to tell you what it is. But, you know, if you put that special name there, I might consider at least giving you a happy face on your exam, maybe even a quarter-point bonus for knowing a cyclic ester has a slightly different, well, very different name. Number of stereoisomers. I don't think we did this. Well, each stereocenter has 2 possibilities, R or S. Mathematics tells us that if I have 1, 2, 3, 4, 5 elements, 6, 1, 2, 3, 4, 5, 6, 6 elements that have 2 choices, 2 to the power of 6 is your answer here. And you're saying, oh, no, we're not allowed to use a calculator. What do I do? All right, I got something for you. It's going to take a second. I'm going over to the test where I got this, and I'll scoot it over here. I got to rotate it counterclockwise. So I can only go clockwise. I got to do 3 clockwise. This is the same as 1 counterclockwise. That page was sideways, that's why. At the very beginning of your exam, where you know questions 1 through 6 will be the same, similar format to yours, I want to point out question 3 has all the math done for you. Question 3, right here, all the powers of 2 in a row. I don't know if I messed up. I'm going to copy it over here. I'm going to go and pick the 6th answer. The 6th answer is 2 to the power of 6. There's 2 to the power of 1, 2, 3, 4, 5, 6. All right. 1, 2, 3, 4, 5, 6. So if you have that one's actually not too bad. You could do that on your own, but if you had like 12 stereo centers, I don't want to figure that out. Okay. Remember, probably your question 3 again. I don't know. Maybe your question 2. Just look for the how many possible stereoisomers question is. Now, typically in nature, only one of those exists. That's how molecules are assembled with enzymes, right? And they have only one-handed way of delivering a stereocenter during synthesis. So there you go. And I think that's all for that. Good. It's very good. Shorter segment. And we'll be back. Believe it or not, we'll be back to finish chapter 5. See you then.